Hello again, welcome back. In this video we're going to go over the material in section 1.1 of your textbook. Okay, so during this short video we're going to talk mostly about vocabulary, and we're going to talk about the difference between qualitative and quantitative variables. And we're going to talk about the difference between discrete and continuous variables. And we're going to talk about something called level of measurement. There's 4 different levels of measurement. We'll talk about the difference between those. Now, I guess first, let's talk about the difference between a population and a sample. And so these are 2 vocabulary words that are sort of related to each other. Now, a public health specialist wants to determine the distribution of body weight for adult males in the United States. So what she does, she enlists a group of 10,000 men just to submit their body weight. And after this, after she collects the data and organizes it, she reports that the average body weight of a man in the United States is 198 pounds. And so the questions are, what is the population and what is the sample? The population, what we mean by this word population, is the group that we're trying to study, or the process that we're trying to study. And what we're trying to study right now is adult males in the United States. So the set of all adult males in the United States, that would be the population for this study. Now, the sample is going to be, where do we actually take the data from, right? What is the set of all the individuals from whom we actually take data that we use to draw an inference about the population? And so the sample is just going to be this group of 10,000 men that actually submitted their body weight. That's where we're actually getting our data from. So we're trying to study the group of all adult males in the United States, and we're studying that population by taking a smaller sample. Now, this is kind of what I already said. The population is the group about which we are trying to make an inference. The sample is the group that we actually measure and study. Just one more example here. The FDA is trying to determine whether 40 milligrams daily omeprazole is safe for adult females who are suffering from heartburn. So the FDA enlists a group of 50,000 women who suffer from heartburn. Half of them are given 40 milligrams daily omeprazole, and the other half are just given a placebo capsule that looks identical to the omeprazole capsule, right? So that way they don't realize that they are part of the control group, the group that's receiving the placebo. But here, what is the population? What is the sample? Again, the population, which is the group that we're trying to make an inference about, is basically all adult females who suffer from heartburn. This is our population. And then our sample, basically where do we get the data from? Our sample is this group of 50,000 women that are actually participating in our experiment. Now, 2 more vocabulary words that come as a pair are going to be parameter and statistic. So these are very similar, but there's important differences here between a parameter and a statistic. A parameter is a characteristic of a population or a process, whereas a statistic is an estimate of a parameter. That's maybe the one thing that you should remember from this slide, is a statistic is just an estimate of a parameter that we calculate from a sample of data. Now, most of the time, we can never ever know the true value of parameters. And so we want to know the true value of a parameter, maybe, right? So this is the thing that we're trying to make an inference about. But most of the time, we can never actually know that. And I'll illustrate these with an example. So suppose a biologist wants to learn about red kangaroos. And the biologist finds 70 red kangaroos in the wild And when you find a red kangaroo in the wild, maybe you sedate them, some kind of sedative, and then once they're sedated, then you can put the kangaroo on a scale and you can weigh the kangaroo. And what we find is that the average weight of these 70 kangaroos is 105 pounds. However, just because the average weight of these 70 kangaroos is 105 pounds, that doesn't mean that the average weight of all kangaroos is 105 pounds, right? So what we would say here is that the statistic is the average weight of 70 kangaroos. The statistic is saying, what we can calculate about our sample is that their average weight of the sample is 105 pounds. And yet, if it turned out that the average weight of all red kangaroos in the whole world is 101 pounds, that would be a parameter. So remember, the parameter is actually a characteristic of the whole population, or the characteristic of a process that we want to know about. But like in this case, we can never really know the value of the parameter. We can never actually instantaneously take the weight of every single red kangaroo in the world. That would just be impossible. The best thing that we can do is take a large enough sample size of these kangaroos and calculate a statistic that's a good estimate of our parameter. So just to repeat myself, a statistic is just an estimate of a parameter. A parameter is a characteristic of a population that we want to know about. So what we do is we take a sample out of that population, we calculate the statistic, and then we say, well, for all we know, this statistic is close enough to our parameter that we're trying to study. Oh, and here I've already put that up. So now, again, another pair of vocabulary words that sort of go together is qualitative variables and quantitative variables. And so a qualitative variable is one that places individuals or places measurements into categories. And so we also call these categorical variables. So whether I say qualitative variable or categorical variable, I mean exactly the same thing. Now a quantitative variable is different. So a quantitative variable is one that assigns a number value to a characteristic. And so maybe this will make more sense here in a second if I give you an example. So consider this bird. This bird is a finch. And suppose a biologist goes to study finches on an island. And what she does is she records the color of the first 100 finches that she finds. And so she finds 40 green finches, 14 orange finches, 22 blue finches, and 24 pink finches. We might ask ourselves, is color going to be a qualitative or quantitative variable? And this is going to be a qualitative variable because remember, qualitative means the same thing as categorical. And what we're doing when we find a finch is we're placing that finch into a category. And the category is the color of the finch. And so this is not quantitative because, well, you'll see an example of quantitative here in a moment. But this is an example of categorical or qualitative. Now, a biologist goes to study finches on an island. She records the beak length. The beak length of each finch in the first 100 finches that she catches. And what she finds is when she takes the sample mean, so she averages the beak lengths. Sample mean just means the average. What she finds is the average beak length of those 100 finches is 10 millimeters. And she might also calculate what we call the sample standard deviation. And we can ask, is beak length a qualitative or quantitative variable? Well, in this case, when we find a finch, we're not placing it into a category. What we're doing each time we find a finch is we're measuring the length of the beak, which has a number value to it in millimeters. And so this is a quantitative variable example. Now, a discrete variable is a variable that has only a countable number of possible values, whereas a continuous variable can take on a continuous range of possible values. And so one way to visualize discrete is to think of maybe like a staircase. Whereas if you are climbing a staircase, you can only achieve certain values of height, or values of altitude, if you will. At the bottom of the staircase, you are 0 feet above the floor. On the first step, you're 1 foot above the floor, and on the second step, you're 2 feet above the floor, and so on. And so your height, if you're climbing in a staircase and you're on each step of the staircase, has to be one of these discrete values. You can't have a value in between these steps. Whereas a continuous variable would be kind of like climbing a ramp. And so if you are just walking up a ramp, you can take on any number value for height, right? So your height at some point along the ramp might be 1.7139825, right? You can have any value that you want as long as you're climbing, a continuously increasing surface like a ramp. And so this is the difference between discrete and continuous variables. Now suppose our biologist goes back to the island to study finches again. And what she does is she records the number of eggs in each of the first 30 nests she finds. So she's finding nests of these birds, and she records how many eggs are in each nest. And so she can calculate the sample mean and sample standard deviation. But the question that we're concerned about now is the number of eggs a discrete or continuous variable. And in our case, this is a discrete variable because the number of eggs that we're allowed to record could be 0 eggs, 1 egg, 2 egg, 3 egg, and so on. But we would not be allowed, for example, we wouldn't be allowed to have 1.7139 eggs. That just wouldn't make any sense. And so the number of eggs that we find in a nest is a discrete variable. On the other hand, again, if we're talking about beak length in the first 100 finches, we ask, is beak length a discrete or continuous variable? Well, length is a continuous variable because a beak could be any length you want, right? It would be okay to have a beak that's 1.7139 millimeters, be a very short beak, but we can have any number of beak length in a range of numbers, right? We're not confined to having beaks that are exactly single multiples of millimeters or centimeters or whatever. Okay, the last thing is level of measurement. So nominal is referring to a measurement where we just categorize things. There's no order to the categories. And so maybe as an example here, I'm going to write example. If we're watching cars go by, like you're sitting at the intersection in your neighborhood and you're watching cars go by, you might categorize those cars into red cars, black cars, white cars, gray cars, and so on. And there's really no order to the categories, right? You wouldn't say that red cars are greater than brown cars. That doesn't make any sense. And so we say that this would be a nominal level of measurement, the way that we're categorizing these cars going by. Now the next step here is an ordinal level of measurement, which gives us a little bit more room to do statistics. And the ordinal level of measurement is saying that we're categorizing, but the categories belong in a particular order. So, an example of categories that belong in a particular order might be students who are done with school, or maybe we should say maybe you choose a bunch of 30-year-olds. And if we take a bunch of 30-year-olds, we could categorize them like this. We could categorize them into 30-year-olds that, let's say, dropped out of high school and never earned their GED. we could categorize them into 30-year-olds that have a GED, 30-year-olds that have an associate's degree, 30-year-olds that have earned their bachelor's, or their 4-year degree, and 30-year-olds that have earned their master's degree, and 30-year-olds that have earned a PhD, or professional degree. And so here, in the ordinal level of measurement, we've taken a sample of 30-year-old people, and we've categorized them, but you recognize that there is an order to these categories, right? So if you're talking about level of educational attainment, you would say, well, having a PhD would be the highest level of degree that you could be awarded for educational attainment. And you can see that there's an order that goes up from no GED all the way up through PhD. Okay, interval level of measurement. It would be saying that we have categories and they have an order to them, and the differences between categories, that actually means something. And so a good example, I think, of an interval level of measurement would be like the Fahrenheit scale when we're measuring temperature. I hope I spelled this correctly. Probably butchered that spelling. But the deal with Fahrenheit is this, right? So you can categorize the temperature outside, or maybe a better word would be to measure the temperature outside, as being like 0 Fahrenheit, 32 Fahrenheit, 100 Fahrenheit, 212 Fahrenheit, and so on. And actually, the difference between the categories means something. And so whenever we go up from, let's say, 30 Fahrenheit up to 40 Fahrenheit, and then 40 to 50 Fahrenheit, the 10-degree difference is actually supposed to mean roughly the same thing when we go from 30 to 40 as going from 40 to 50. That kind of means the same thing as going from like 300 to 310. Like a degree Fahrenheit represents, a certain meaning in terms of temperature. So the difference actually means something. Whereas if you're talking about the ordinal degree of measurement, the difference between interval and ordinal, an ordinal level of measurement, this might be different, right? So like going from an associate's degree to a bachelor's degree, this is typically a difference of like 2 years, right? An associate's degree is traditionally a 2-year degree, and a bachelor's is traditionally a 4-year degree. But sometimes you can get your master's degree in just 1 year. I've seen programs where you can go from bachelor's to master's in 1 year. I've seen other programs where it takes 3 years to go from bachelor's to master's. Going from no GED to having a GED, this could take a variable amount of time, depending on, where you're at, I think, before you go into the program. And then actually going from a master's to a PhD usually takes many years, so maybe something like 4 years, right? And so just because these are consecutive categories, it doesn't necessarily mean that the difference between those categories is always the same. And then finally, sort of the best level of measurement, or the thing that leaves us the most room for which we can do math and do statistics with our measurements or with our data. The highest level of measurement is what we call a ratio level of measurement. And so ratios actually mean something whenever we're talking about ratios between values. And so maybe a good example of a ratio measurement might be like sorry, I'm coming up with these on the fly here. But the mass of cotton yield. So if you are a cotton farmer, maybe you measure how much cotton did you bring in during the course of the year as you're selling it. And, the mass of cotton that you're actually getting, it's kind of even a better measurement than these other types of measurements. Because, for example, let's say one year you bring in like 1,000 kilograms, and that's probably way too small, honestly. But I'm just making up numbers here. So, and then another year you bring in 500 kilograms. So going from one year to the next, you can actually say, I brought in half as much cotton yield this year as I did last year. And, or you could say, you know, like last year I collected twice as much cotton. And so there's actually the ratio between these values means something. And notice that ratio is just like an interval level of measurement, except for, you know, this idea that 0 means 0. You know, if you bring in 0 kilograms of cotton one year, that means you actually did not collect anything. And so that's the ratio level of measurement. And again, that's the level of measurement that we like the most because it allows us to do math with it and really dig in to the statistical analysis. I also want to point out that whenever we're talking about the interval level of measurement, this specifically has the property where 0 doesn't really mean 0. And so on the Fahrenheit scale, I invite you to think about this for a moment. On the Fahrenheit scale, 0 degrees Fahrenheit does not mean that you don't have a temperature, right? You can actually go into the negative Fahrenheits, right? You can have like -5 degrees Fahrenheit. And there's nothing appreciably different that happens between like -5 and +5 Fahrenheit, right? So having a negative temperature, that's just, you know, a way of describing how cold something is, but you haven't actually gone into negative quantities of anything. So 0 doesn't really mean 0. You know, you still have a temperature even when it's 0 degrees Fahrenheit outside. Whereas if you have 0 kilograms of cotton, that literally means you don't have any cotton. And the other thing is if we were going from 10 degrees Fahrenheit up to 20 degrees Fahrenheit in like 2 consecutive days, right? I wouldn't say, oh, it's twice as hot outside today as it was yesterday. That just wouldn't make any sense, right? In fact, you know, going from 10 to 20 is, you know, it's really, you know, what am I trying to say? It's really the same thing as like going from like 210 Fahrenheit to 220, right? So the ratio doesn't matter, but the differences between the categories actually do mean something. Again, just to really, really drive this point home, if it's 1 degree Fahrenheit one day, and then the next day it's 7 degrees Fahrenheit, you wouldn't say, oh, it's 7 times as hot, right? And if it's -2 Fahrenheit, and then the next day it's 4 Fahrenheit, you wouldn't say, oh, it's -2 times as hot, because of course -2 times -2 gives you 4. You wouldn't say it's -2 times as hot today as it was yesterday. So basically what I'm trying to say, the difference between interval level of measurement and ratio level of measurement is that for ratio levels of measurement, the ratios between values, that actually means something.